Welcome to Module 6 of our video tutorials on how to program DSP using Code Composure Studio. In this tutorial, we will see how to configure timer 0. Using the standard procedure, we will first initialize the DSP. Then, we will first disable all the interrupts. Please note that doing so will disable even the timer 0 interrupts. Using innate CPU timers, we are going to first initialize the underlying hardware of the timers. In step 1, we are going to enable the triggering of CPU 0. For this, we are going to set the bit number 7 of PIE IER in PI control registers as 1. Then, we have to enable the timer 0 interrupt in the interrupt enable register. Please note that IER is initially 0 because of the DINT function call. Here, the timer 0 interrupt is enabled using an appropriate mask. Next, whenever a timer interrupt occurs, the corresponding ISR has to be executed. For this, we need to map the ISR to the timer 0 interrupt call. This is done using the statement where the CPU underscore timer 0 underscore ISR is mapped to TINT0 of PI vector table. Here, PIE is a protected register and requires EAllow permissions, and hence it is written in the EAllow block. After this, we also enable the global and global real-time interrupts. By now, we have already enabled all the interrupts of timer 0. The next step is to configure the time of the timer 0. The config CPU timer does the function. It takes 3 arguments. The first is the name of the timer. Here we are going to write CPU timer 0. The second and third argument are the deciding factors of the time. You have to multiply the second and third argument and divided it with the CPU frequency. Here we have used 150 into 5 into 10 raised to 5 divided by 150 MHz, which accounts to 500 millisecond period. If we write 150 into 10 raised to 6, the CPU timer 0 will be interrupted every 1 second. In step 5, we have to actually start the timer. This is done by writing into the TSS bit of timer 0. This statement does the purpose. Now, in order to have a visible output, we are going to set one of the LED in the timer. We are going to toggle one LED in the CPU timer register. We are now going to configure the GPIO so that one of the LED can be toggled within the CPU ISR. First, we set the bit number. We are now going to configure a GPIO so that we can have a visible output at ISR call. For that, we need to first make a pin as a GPIO function. For that, we write 0 in the mux. Then we have to set the GPIO as an output pin. To do that, in the dir register, we write 1. Within the CPU underscore timer 0 underscore ISR, we are going to write a toggle function for the particular GPIO. Thus, in this code, a GPIO is going to be toggled every 500 milliseconds using a timer 0 ISR call. Let's build this program. Since there are no errors, the build has been successfully completed, and now we debug the code. Once the code is debugged, we can run the code and observe that the LED is toggling every 0.5 seconds. We halt and terminate the connection. Thank you.